Good morning, everyone. Welcome to Serverless Days Cardiff. It's pretty loud. So over the day, you're going to hear about how companies like Lego, The Zone, and many others are using serverless to great success, and how they found serverless to be more scalable, to be more secure, reliable, and allows the teams to go fast as well. And on top of that, also find the architecture to be a lot cheaper. So talk about having the cake and eating it. And you're sitting there thinking, well, that all sounds like pretty good, the promised land, the paradise, but also maybe pretty far from where I am right now. And I'm sitting here working with my monolith, and how do I plot a path from where I am to where I want to be, using serverless for everything and being able to go really, really fast. And that's kind of where I was 3 years ago when I inherited a monolith for a social network with a really long list of problems, including scalability and uptime. And the feature was taking forever to develop. And within 6 months, me and a very small team of developers, 6 people, including myself, we were able to transform that entire thing to move to serverless. And apart from myself, everybody else had no previous experience with AWS. And along the way, we found we were able to save our cost in terms of AC2 down to about 5% of what we were spending, because the traffic was quite spiky. We had a lot of spare capacity lighting around just in case there's a spike. And with serverless, it scales automatically, which is great. But cost was never the reason why we did that transformation in the first place. We found ourselves in a place where feature was really hard to work on. Every line of code you change has knock-on effects that we just couldn't see, and everything was taking a very long time to develop. Feature was taking months to actually get out. And by the time we finished a lot of this transformation to serverless, feature was getting done really, really quickly, mostly in a number of days. And in some cases, we were able to discuss the feature with the product team, design it, implement it, test it, and ship it all within the same day. So my name is Yan Cui. I'm an AWS hero, and I've been working with AWS for over 10 years now. And I've built a few things with serverless, including that social network I just told you about. And nowadays, I spend half of my time working with Lumigo as a developer advocate. And if those of you who are not familiar with Lumigo, we are a serverless monitoring and troubleshooting platform, and we have a booth over there, so go and talk to us. It's right by the coffee and alcohol, so you can't really miss it. And we also give away a drone as well as a surprise. And the other half of my time I spend as an independent consultant working with companies all around the world of all different sizes, providing training and advice, as well as sometimes helping teams deliver features quickly. And in my spare time, what little I have, I also try to put out a lot of content in terms of books, video courses, blog posts, and so on. And my latest video course, Learn You Some Lambda Best Practice for Great Good, just went live last night. So go to lambdabestpractice.com to check it out. The main thing I want to tell you about is that the rapid transformation that I achieved in my team, going from monolith to serverless, is easily replicatable. If I'm honest, everyone can do it. There's nothing special about me or the team that I was working with. But what you do need to do as the first step is create the conditions or the environment in which the success you are looking for can actually be allowed to happen. Many organizations who transitioned from monolith to microservices a few years back, they all employ this technique called reverse Conway's maneuver, named after Melvin Conway's observation in 1967 that organizations that design systems are constrained to reproduce the design, which are copies of the communication structure of those organizations. And when you got organizations who refuse to change the way they operate, and they try to adopt serverless in the hope that magically everything is going to get better because of serverless, eventually they found out that, well, you can't just rely on technologies to solve all the cultural problems that you have. If anything, some of these technology advancements like serverless brings a lot of those cultural problems to the surface. For example, if all of your feature teams are now moving to serverless and they're going really fast, but they still depend on a centralized ops team to release all of their work because they are the only ones that a company trusts with access to the company's production environment, then your maximum velocity is just how fast this central team is able to move. Doesn't matter how much work your feature teams are able to get done, how quickly they get it done using serverless technologies. In fact, the faster they're able to move, the more you're going to feel the pain you get from having this centralized team that have to do the work for everybody. Before, you may not even realize you've got this big bottleneck in your organization because the feature teams might not be moving fast enough to generate enough work for that pressure to be felt. And the argument here, I often hear about this setup is that, well, but our developers just don't understand AWS. They don't know how our infrastructure is set up. To that, I say, well, that's great. You found the root cause. Let's go and address that. Let's go and train and educate your developers. Is everything okay? So educate your developers. So your developers are the ones making all the architectural decisions for the application anyway. Your ops teams can't possibly know and understand everything all the different feature teams are working on all the time, and how can they be expected to support systems that they don't understand? And if you make that ops team the sole responsible for your system's uptime, then you're creating pressure for that team to push back against change, because they are the ones that have to wake up in the morning when something goes wrong at 2 a.m. So essentially, you've incentivized your ops team to slow you down. So instead, you should invest into your developers, upskill them, train them, and make them responsible for the system's uptime. The single most effective way I found to improve a system's uptime is just by putting these developers on the on-call rota. So reverse conebased maneuver basically boils down to you should structure your organization to match the software that you intend to produce. So if you want software that are made of small independent modules that can be deployed and scaled independently, and they can also fail independently without taking down all the other services, then you also want to structure your organization so that you have small autonomous teams that can innovate and move quickly, and also be able to fail in isolation without bringing down everybody else as well. And your job as a decision maker, as a leader, as a manager, senior management, is to empower the teams to make that happen. Of course, you also don't want to end up with the Wild Wild West there where you have no idea what the hell is going on. So instead of focusing and creating a centralized ops team that holds the key to your kingdom, instead, you should invest into monitoring, into automation, and also to apply guardrails into what the teams are doing. Maybe you want to adopt the SRE model, so having an experienced operational team goes and embed into individual feature teams to help upskill the teams, to help train them up, and help them understand how the overall our company's infrastructure is configured and set up, so that you can help the teams and set them up for success. And your job as a leader, again, is to provide guidance and context rather than putting in place all this centralized control and gatekeeping into the organization. And when it comes to forming those teams, you want to align those teams with the problem space they're dealing with as opposed to solution, because the solution changes all the time, but the problem that you're dealing with, they seldom change. And if you're working within a large enterprise, so you have lots of different teams, another painful lesson that you don't want to learn yourself is don't just open a floodgate on day one and let everybody go crazy all at once, because what's going to happen is that everyone is going to run into the same problems. They will have to learn the same lessons and make the same mistakes, so it's just super inefficient in terms of learning as an organization. So instead, identify people who Simon Wilder would describe as pioneers or settlers, people who have, good disposition towards exploring unknown space and uncharted spaces to understand how this new technology works, find out all the problems so that they can then plot a path to success for everybody else to follow without everyone having to then learn the same mistakes along the way as well. But also importantly, just accept that there's something new and that you have to accept that your teams need to scale up and ask for help, give them the training and guidance they need. And from what I hear, Jeremy Daly's DM is open on Twitter, so feel free to go and ask for help, or sign up to his newsletter, Off by None, where he does a great job of collecting everything the community is producing every week. In terms of actually start doing this migration process, the first thing you want to do is identify those service boundaries. And this is where you do want to play safe, and it does pay to play safe, whereby you look at your mind map of how your system is constructed in terms of different problem domains, and then you start with those low-risk, non-critical business functions first, make a success of it, and then use a strangler pattern to incrementally and gradually move your monolith one piece at a time to this new world of serverless. So as the social network example goes, we had a timeline feature just like Twitter, Facebook, and everybody else. But we also have loads of other things around the application as well, like chat, search, and so on, that all involve a number of different entities in the system, such as users, relationships, content, and brand, and so on. All of these things are a good starting point for you to identify what are the service boundaries within my monolith. And then for different boundaries, I can choose the right technology in terms of implementation. Maybe, for example, I want to use DynamoDB as a default, but occasionally I want to draw back to using relational databases. And for things like for implementing the relationships, maybe a graph database is a much better fit compared to a NoSQL database like DynamoDB. What's important is to remember that services need to be autonomous, and they need to have clear boundaries around what the responsibilities are, and also, very importantly, they need to own their data. So many companies, when they move to microservices, end up with a distributed monolith instead, when they have all these different services, have got their own APIs, their own deployment pipeline, everything, but they all talk to and share the same database. That is just a recipe for disaster waiting to happen. So as a microservice, I need to own the data that I operate on so that when someone else goes down, I don't get taken down with it at the same time, because you don't want your database to be a single point of failure in the whole system. And also, you want your microservices to be loosely coupled through events, through these shared contracts. In terms of designing your boundary context, also important to remember that you want to avoid this empty pattern called entity service, whereby you look at one part of your mind map and say, okay, users, let's just put a microservice around that concept of users and put everything they're doing with the users into that microservice in terms of creating users, deleting them, searching them, user-to-user chat, all of that is sort of to do with users. Then you end up with this just big monolith instead. So instead, try to align your microservices with the vertical problem space that you're dealing with. So now you've sort of identified your boundary context, and you start to organize how you're going to put your code into GitHub repos. Another maybe not so common, but I've seen this quite a few times now, is, Lambda functions can be deployed independently and scaled independently, so let's just put a function into every single repo. Of course, you then quickly end up with hundreds of repos, with hundreds of different pipelines, with not enough brain power to actually manage and coordinate all the different deployments, so definitely do not do that. The two approaches that actually work is either you go down the monorepo approach, whereby all of your functions sit inside the same repo, they are still separating services, so we see in your monorepo, you have a folder for every service, and then every service will have its own deployment pipeline, but they can share codes through Symlink or through Webpack, where you have using relative path, and then just rely on something like Webpack to bundle everything together at deployment time. And then you will deploy all of your services with a single pipeline and just do them in parallel. So this approach works well until you hit about 100 to about 150 engineers, at which point everyone's committing to the same repo. It just becomes really, really, really troublesome. And at that point, you're going to need some really good automation tooling to actually make this work. And when you hear about companies like Google and Twitter and all these big tech companies all using monorepos, you don't hear about how they invested years and teams of engineers building a lot of those automations and guardrail in order for them to do monorepos well and safely as well. And I'm guessing most of you just don't have the resources that these companies can throw at this problem of building tooling in order for the company to be able to use monorepos going forward as well. That said, monorepos are great when you're a small team with a very few engineers in the team, whereby you get all the benefits you get from monorepo and none of the problems. And hopefully, with serverless, all of your developers are so productive anyway, so you don't end up having to hire hundreds and hundreds of developers just to get things done. The approach that I tend to go with, as I work with lots of, bigger companies, is we will have one repo per service, and then you have all the functions that are working together for that particular service sitting inside the same repo, inside the same stack. So you have different engineers grouping into different teams that are aligned with different problem domains you have that you're facing, and then they will have different microservices. One team may own one or more microservices, and every microservice will have its own GitHub repo with all the resources, including the functions, as well as all the databases and API gateways and so on. And then you have one single CI/CD pipeline per service and per repo, therefore. And if you've got shared infrastructure, things like VPCs and so on, then maybe you also want to put them into a separate repo that's got its own deployment cycle, so that when you want to update the VPC configuration, there's a separate repo that you can go and do that. And then you can reference those shared infrastructure via CloudFormation outputs, SSM parameters, and whatever you want to do. And in terms of sharing code between different microservices, well, I still think you should go through shared packages through NPM, Maven, or whatever. Then if for some business logic that you want to make sure that everybody is doing exactly the same thing, the same way, so you want to enforce consistency, that's when maybe shared code is not such a good idea in terms of distributing packages and libraries, and instead you want to have a shared services instead. So I wrote a blog post a while back about the two different approaches, the pros and cons, and in terms of the shared services, the main thing is that the service owner owns the release cycle for that, an update cycle for those shared logic. So we decided how you're going to organize your code, where your boundary contexts are. The next thing you got to do is just pick your tooling in terms of the deployment frameworks, the CI/CD tools you want to use, what you're going to use for monitoring your systems and alerting and all of that. And I get asked a lot is, what is the best tool for this, for X? Unfortunately, there's just no best tool for whatever it is you're looking at. But there may be a best tool for you based on the constraints you're working with, based on your requirements. So always start with what would the good solution look like for us, and then look at the tools and see what they do, and pick the tool that ticks the most boxes and the least amount of workaround you have to do in order to get it to work for you. In terms of deployment tooling, there's just so much of them out there already. And a while back, I wrote another blog post that compares all the different deployment tooling in terms of how opinionated they are, but also in terms of whether or not they give you the ability to customize when you don't agree with the opinions of the framework. The most important thing is don't go and derive your own deployment framework. It's exactly the kind of undifferentiated heavy lifting that we want to get away from with serverless. Having spent all this time to maintain and write your own deployment framework, rather than working on what's actually important for your business, is just not the time that's worth spending. That said, once you pick a tool, try to standardize across the entire organization. You also don't want to be in a situation whereby every single team is using a different framework, so that people move from one team to another. They have to learn the new business domain, the business logic, but also how do we deploy our stuff with this different tool that I'm not used to. And instead, standardize the tool you want to use, whatever it is, so that you can maximize institutional knowledge sharing. And as you start to write your Lambda functions or your Azure functions and so on, it's also important then to make sure your functions just are simple. A lot of the sort of things that we've used to doing back in the day, writing all this one big Express app with lots of handling function all inside, just not going to really work well when it comes to serverless world, whereby you could have a fat function that does all the routing and handle all the requests for a single API. But the idiomatic way of doing things in the serverless world is to have one function per endpoint per action. When you compare the two approaches, what I call a fat or monolith function versus single-purpose function, you end up with a lot more functions, but at the same time, you can also very easily find related functions together by prefix, by name. And this is something that frameworks like SAM and the server framework gives you out of the box already. So in terms of what capabilities that we have from the system, it's actually more easy to discover that when you got functions with well-named names, that tells you, okay, we've got the capabilities to add user and then get user by Facebook ID, get user by Twitter ID, and so on. Whereas with the fat function, I have to go into the code just to see what are the business capabilities that we have with this function. Another thing when it comes to security is that your different functions may be doing different things. They need different assets. And with single-purpose functions, you can be very specific about what the permission that each of those functions needs. Whereas with the fat function that does absolutely everything, it needs to have way more permissions than otherwise is required, which means also you're now breaking the golden rule in security, which is the principle of least privilege. Another thing in terms of performance is that all of your functions, to do their job, they need to have some dependencies and they need to get something from NPM or Maven or whatever. And for the fat function that does everything, well, it also needs to have the dependencies to do absolutely everything the entire API can do. So if you've got an API that does some server-side rendering with React, but also lots of REST API stuff, then that single function needs to have needs to depend on React, which is a really big dependency, but also the AWS CK, the fixable ID, and everything else that needs to do the job for the entire API. And when you look at the cold start performance for a function, what you see oftentimes is that most of the cold start is attributed to the time it takes to initialize your function. So that's the time it takes to require all the dependency that your function has. So having a function that has got lots more dependencies is going to hurt you as well when it comes to the performance during cold start. So keep your function simple and single purpose. And then the big one is, okay, we've got a new microservice running on serverless technology, all ready to go. How do we then gracefully migrate to this new service? So we start from the world whereby we got this gigantic monolith with every feature inside it, all talking to a shared database. And they all access the database directly, going to tables and whatnot. And we want to move to the world where this particular feature has been moved into a microservice and owns its own database. And everybody that needs to access data or create a new user, they have to go through this shared service. However, if you want to do this big bang, then that requires a lot of challenges. Also, it's very risky as well. If you want to do everything, migrate everything at the same time. So instead, most of the time, you want to start nice and safe and gradually instead migrate over gradually, where you move the feature logic to a new microservice, but still talking to your shared monolith database, and then gradually starting with the least critical component, migrate it over to access data not directly through the database, but through the shared service instead. And then as you prove that actually works and scales and no problem, then you start to migrate more and more of the services over so that you cut off those direct access to the shared database. And then eventually, at least your new service, your new microservice, is owning access to that particular piece of data. That's when you can start thinking about, okay, now let's put in place a new replacement database. It could be MongoDB, it could be DynamoDB, or whatever. If you can do the migration with some downtime, absolutely go and do it. It's so much easier. When you can just say, you know what, we're going to accept some disruption, have some couple hours of downtime, and just migrate all the data over. But if you can't do that, and many of our systems nowadays have to stay up 24/7 because we have global users that use the system all the time, then you consider this approach whereby essentially you turn your new database as a read-through and write-through cache. So whenever you need to update some data, update it in the monolith database, but also then update in the new database. And when you want to read something, check the new database first. If it's not there, then go and fetch it from the monolith, the legacy database, and then put it back in. And in the meantime, your system is still up and running. There's no downtime that's required. And at the same time, you kick off some background synchronization job that takes all the data from your legacy database into your new database in the background, and make sure that while you're doing that, you're using things like conditional writes with DynamoDB so that you don't overwrite the new data you just written with old data that you're still processing from the background job, until eventually all the data is now in the new database that's owned by your new microservice running on serverless technologies. Then you can switch everything over to your new database and you're ready. As you can see, it can be a long and painful process, but context is king here. And if you are, say, a small startup, and I'll actually recommend that, and the cost of having some disruption is actually minimal, then just take the hit and just keep things simple and easy for yourself. But for large enterprises, they value stability and safety and risk averse more than anything else, then take the pain, take the slow and painful road that gets you there safely instead. Another thing to keep in mind, just in terms of your API surface, if you want to introduce some API changes, how do you go and do that? I've tried all these different versioning schemes to have the version in the URL, HTTP headers, have some kind of context that you can switch on the server side. All of them suck. So I keep going back and forth, but always end up in the same place, which is just keep API back compatibility. If you want to introduce a new field or rename a field, just keep the old field there anyway. until eventually you know no one's using it. Maybe you employ some technique like what Facebook does, whereby when they want to deprecate something, they give you warning that, hey, 6 months ago, this thing is going to be deprecated, and then gradually they're going to occasionally just fail the request. And as time gets closer and closer to D-Day, you fail more and more of the requests, so that people start looking at, wait a minute, why is this thing failing? Let's go and check it out. And realize, oh, right, error message says this is going to be deprecated in a month. Please go and do something. And when it comes to communication between microservices, and depending on data that's owned by other microservices, you usually prefer synchronizing the data and taking copies of it over having to make a synchronous API call at runtime. So imagine you've got some user-facing APIs or edge APIs that depend on some data that's owned by other microservices. So in this case, System C is your single point of failure, so that if everybody have to ask System C for some data at runtime, then System C goes down, then everybody goes down as well, and you have a cascade failure on your hands. So a much better way to do this is for System C to own the data, be the authority of data, but whenever it updates them, publish an event that other systems can listen to and take a copy of it, at least the data that they need for their purpose, and save it to their own database, so that at runtime, if the System C goes down, everybody else can still stay up, because all they're doing is reading data from their own database. Remember, microservices needs to own their own data in order to be autonomous, in order to be independent when it comes to failures. This copying works great, except when it comes to GDPR. So if you got user data or PII data being copied everywhere, then it's going to be a nightmare for you to say, okay, actually delete that user's data when they ask for it. So one piece of data I never copy, which is just any of the PII data. If it's owned by one microservice, okay, that's fine. At least we have one place we need to go and deal with it when someone asks to delete their data from our system, rather than have to go and delete that data everywhere else as well. And as you're getting deeper and deeper into this world of writing stuff with, working with serverless technologies, you also want to rethink the way you do testing as well. In your monolith, you probably have lots of unit tests, few integration tests, and even few acceptance tests as well. But since most Lambda functions are actually really simple, they don't do an awful lot, and they're single-purposed. And I find that most of the problem that happen is just how your function integrates with other services. And those kind of integration, you just don't test them very well when it comes to unit tests, where you're mocking every single dependency, and you're not flagging those integration-related problems. And as Paul Johnson said a long time ago, that I think fundamentally, serverless just requires a different way of thinking, because we have different risk profile when it comes to what can go wrong. And if all you're doing to test your system is writing unit tests and you're mocking all of your dependencies, then you're actually not going to test most of the things that can actually go wrong at runtime. Things like permissions, things like how you're interacting with those different services. And just because you have a passing test, just because all of your tests are passing, it doesn't mean that you've got a working system. When you've got a working system, then you've got a working system. And this frustrates me to no end, that a lot of developers says, well, but then my feedback loop is really slow when I don't have all these unit tests. So instead, you're optimizing how good you feel working on the code, as opposed to what's actually important, which is, well, is your system working? What are the user experience that you're delivering to your customers? So all my pro tip is that just avoid local simulation as much as you can. All these things like local stack, all these different tools exist, and I think it's great that they exist, but they take so much work to set up. I've had teams spend a week setting up a local stack, while other teams already delivered and shipped to production and have gone home. And also, when you're writing tests, prefer to write them at a high level, so your tests are not deeply coupled to implementation details. When I write tests for APIs, for example, I write them very high level, that when we hit this endpoint, what are the expected outcome? And I run my tests such that I can run them as integration tests, so that I'll run the code locally on CI and toggle into the real AWS services. And then when I get a good confidence that everything is working, business logic-wise, I will deploy that, have a new API ready to run, and then I'll run the same test cases, because again, they're all very high level, but talk to the real HTTP endpoint that's been created. And to do that, I just have a little toggle inside my code that says, okay, depending on some environment variable, we will either call the function locally as integration, or we're going to hit the real API endpoint that's been deployed. And I'll only use, I don't I only use mocks for AWS services to simulate failure conditions that are otherwise difficult to simulate with the real thing. But I always use mocks for internal APIs because our API is just not as stable as AWS or other services. People deploy things to their environment, break things all the time, and you don't want a single team to break everybody's pipeline so no one can run any test. And also, when you run the end-to-end tests, try to use a temporary stack so that you don't have to get into this world of having to manage the data that you deploy to your shared environments. And if you want to include things like SNS and Kinesis and all these difficult event sources, destinations as part of end-to-end tests, I also wrote a blog post about how you can include those in your end-to-end tests as well. And finally, you want to think about resilience. You get a lot of resilience out of the box, but in order for you to build a truly resilient system, the first thing you need to have is the ability to find out when something goes wrong quickly and be able to debug it. And Aviad, the CTO from Lumigo, is going to tell us all about that later on. And then there's all these different resilience patterns you can apply, such as using queues to amortize traffic spikes between different services, and then using the Saga pattern to manage the distributed transaction, or having circuit breakers to help prevent those cascade failures and retry storms, or having bulkheads just to isolate failures into individual accounts, individual microservices, or individual threads. And the one and only Jeremy Daly is going to tell us all about how to build resilient systems using serverless later on. And I think the golden rule when it comes to building a resilient serverless application is to go multi-region, active-active. And this is something that we did everywhere at the Zone. And Sarah from the Zone is going to tell us all about that, as well as other failure modes when it comes to serverless applications. So that's my 8 steps to migrate a monolith to serverless. First, look at how your organization is structured, and structure it the way that allow you to succeed in this new world of serverless and create small autonomous teams that are empowered to do what they need to do and give them support and help them train and skill up. Identify your boundary context, organize your code base into either monorepo or one repo per microservice, pick your deployment tools and CI tools and stick to them, and keep your functions simple, and then migrate to your new services gracefully and gradually, especially if you're enterprise and you care about stability and safety. And then rethink how you're doing testing and how you're going to make things more resilient. And so that's everything I have. If you want to get in touch with me, you can go to my blog, theburninman.com, and you can also talk to me as well about how we can work together to help you create a success story with serverless. And I also partnered up with Anne Stanley, one of the organizers for Serverless Days globally, to run my workshop, a 2-day workshop in London. So go to his platform, sensor.io, to check it out. And with that, thank you guys very much for your time, and enjoy and have a great conference.